Vertex form. Sounds fun. Let's do some graphing. Here's the essential question. How can I use transformations to graph parabolas? Remember transformations? We did them back with absolute value functions. We had the shift right or left. We had the shift up or down. We had the stretch. These transformations are going to work exactly the same way with parabolas. That's why it's so useful that you already learned them. So this h is still going to mean a shift right or left. This k is still going to mean a shift up or down. And this a is still going to be our stretch. Now, keep in mind, with a parabola, we have something called the vertex, and it's at the very bottom of the graph. Typically, the vertex is at 0, 0. But when we shift the function, it's going to shift according to h and k, and so the vertex is actually going to end up being at h, k. How cool is that? So we can use hk to find the vertex. Yay! Let's do some examples. First, let's start by graphing y equals negative 1/4 x plus 2 squared plus 5. First, let's start by identifying the vertex. The vertex, remember, is h, k. Remember that this is backwards. So my vertex is negative 2, 5. So let's plot that point. Over negative 2 up 5. Keep in mind the transformation that's going on here is that I've shifted left 2 and up 5. The a is my stretch. So I know I'm going to be stretching by negative 1/4. That means my parabola is going to be going down, and it's going to be a little bit like shorter than it normally is. It's not going to go up as fast. Anyway, we don't need to do that directly. Let's just pick some points, just like we always do. So I have my XY chart. I want to put the vertex in the middle. We already know it's negative 2, 5. Let's pick some x's to the left. Let's pick some x's to the right. And remember, I'm going to be able to use symmetry in this problem. Now, let's do this. Since I'm actually going to be multiplying by 1/4, maybe I can pick my values a little more intelligently than I did here. Since I'm going to be multiplying by 1/4, let's pick some even numbers. So like 0 will be good. Negative 4 on the other side. Since I'm going up 2, I can go down 2 here. And then we can do 2. So I'll go down to negative 6 then. So let's just use even numbers. That'll be easier. Okay, so negative 1/4 times 0 plus 2 squared plus 5. Let's see. 0 plus 2 is 2. 2 squared is 4. 4 times negative 1/4 is negative 1. And negative 1 plus 5 is 4. So if I go over 0, I'm going up 4. Next, we can use symmetry. Remember, if I'm going up 4 on that side, I'm also going to go up 4 on the other side. So make use of the symmetry. Next, we're plugging in 2. So negative 1 over 4 times 2 plus 2 squared plus 5. Okay, 2 plus 2 is 4. 4 squared is 16. 16 times negative 1/4 is negative 4. Negative 4 plus 5 is 1. So if I go over 2, I'm going up 1. And if I'm going over negative 6, I'm also going up 1. Make use of that sweet, sweet symmetry. And you can graph that nice, smooth parabola. Sweet. Okay, moving on. Next problem. First of all, let's start off by identifying the vertex. The vertex in this case, remember, h, k, and the h is opposite. So I'm doing 1, negative 8. Remember, this means it's a shift right of 1 and a shift down of 8. That's this point. Making my XY table, let's put the vertex right in the middle as we always do. Don't know why I wrote the negative there. Silly Mr. Gregory. Okay, now we can pick 2 points on either side. Let's go 2, 3, and then moving down 0, negative 1. I'm going up by 1 each time, so I want to go down by 1 on each time on the other side to utilicize the reflection thingy. So let's take a look at some points. When I plug in 2, I have 2 times 2 minus 1 squared minus 8. 2 minus 1 is 1. 1 squared is still 1. 1 times 2 is 2, and 2 minus 8 is negative 6. So if I go over 2, I'm going down 6. That will be the same on the other side. Very nice. How about 3? When I plug in 3, I have 3 minus 1, which is 2. 2 squared is 4. 4 times 8 is 8, and 8 minus 8 is 0. So if I go over 3, I'm going up 0. Let's use that symmetry on the other side. Here's my parabola, and I guess I can finish by filling in the xy table. It wasn't really doing that as I go. Cool beans. Moving on. One more problem. This guy is in vertex form right now. Vertex form is very useful for graphing. I think it's far easier for graphing than standard form, but sometimes we want things to be in standard form. Like for example, if we're using the quadratic formula, we need it to be in standard form. Remember, standard form is ax squared plus bx plus c, and clearly vertex form is not standard form because I have some parentheses. How can I make it in standard form? Basically, I just need to get rid of the parentheses. And to do that for this problem, that means, well, what does it mean? Some people think that they should distribute this 2 in. It's a bad idea. It's conflicting with order of operations because the squaring has to come before the multiplying, so don't do that. Some people also think that you need to distribute the square in. Also a bad idea. That doesn't work because what does a square really mean? A square means do what is there twice. So I have y equals 2 times x minus 1 times x minus 1. Do you see how I took this x minus 1 squared and I wrote it out x minus 1 times x minus 1? That's because x minus 1 squared literally means, hey, do that times itself twice. And this turns into a FOIL problem. So let's do the FOIL. I'm going to leave 2 outside. Sometimes people get confused about that. Don't distribute 2 in until the end. And I'm going to FOIL this. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And I'll rewrite the rest of my equation. I can combine like terms within the parenthesis. So we see negative x minus x is negative 2x. Finally, now since I've gotten rid of the exponent outside of the parentheses, there's no exponent there anymore, that means that I can in fact now distribute the 2 in. So 2x squared minus 4x plus 2 minus 8, and all that's left is to combine the like terms. My final answer will be y equals 2x squared minus 4x minus 6. That looks like it's in standard form. I have ax squared plus bx plus c. None of this vertex form nonsense. Hey, that was a pretty short video. Let's get right on to the summary. Steps to graph. If we have something in what is called vertex form, so yeah, a times x minus h squared plus k, remember that the vertex is given by h, comma, k. From there, we can make an XY table. I'd put the vertex right in the middle so that we can make use of symmetry, just like the last problem, or the last day. All right, thank you for watching. Good luck graphing, students.